Hi guys, welcome to iEntrop. It's day 76 of DSA learning. And first of all, very good morning to all of you. And let's begin without wasting time because today I'm targeting to solve at least two problems. Let's see how it goes. Fingers crossed, and let's begin. So okay, so so what is the plan for today? First thing is like yesterday I was watching Lead Code Weekly contest. Uh, I was able to solve only one problem, and there were four problems. So I'm gonna watch the solution for those remaining problems. Yesterday I was trying to understand the solution for one problem. That is second problem. I thought it can be solved using dynamic programming, uh, but somehow it ended up with like it is solvable. We can solve using dynamic programming, but the problem is like the time complexity issue, like when you are using and when time constraint is given like 10 to the power 5, then you will end up with 10 to the power 10. That is not acceptable. So that's why when we are using two loops it's not working. So there was some sort of uh, like when I watched video, then there was some sort of solution for it where we are using or we are dealing with variables. So still it's a little new and off topic to understand or to grasp. So I mean, not off topic, I would say it's like a kind of thing that I never solved in a such a way. I never thought in that way. So definitely it's a new experience, and it is taking time to grasp the knowledge, grasp the concept. So but yeah, we'll do it. And other than that, what else? Okay, so first we will solve the take you forward, like on the platform take you forward uh, problem. We will try to solve one problem and then we'll jump into it. So okay, let me transition first. Okay, so the thing is, okay, here what needs to be done, we need to open the quick time player so that we can see the draw whiteboard, our whiteboard. Great, thanks to uh, my iPad. Hi there. Let's jump and let me start timer also. So we will target only 1 hour, 2 hours. So 2 hours, 2 hours, clock. Come on. 1 hour, 2 hours, 00 minutes. Start and let's begin. Okay. What is it? It is two. Was it 2 hours or what? Yeah, it's 2 hours. So when I'm saying 2 hours, it feels like I'm saying 2 hours. DP analyze, so longest increasing subsequence. This was little tricky for me to grasp the concept. I was confused. Like I was confused. I get confused when I was trying to solve it, and the reason was simple because I was trying to think about it, like how it actually behaves, and somewhere I was getting confused. Somewhere I was confusing, like when I was trying to solve it. So okay, no problem. Print longest increasing subsequence. Okay. So is it sound okay? It looks like similar to the print long. Okay, longest increasing subsequence, print longest common subsequence. So simply similar to the longest common subsequence. Okay, let's do it. Let's do it. Okay, given an array of integers array, return the longest increasing subsequence that is index wise lexicographically smallest. Oh, okay. Where all the elements are in a strictly increasing order. A subsequence even is index-wise lexicographically smaller than another subsequence A2. If the first position where A1 and A2 differ, the element in A1 appears earlier in the array than corresponding element in S2. Okay, so if we talk about, like, suppose one is starting from 10, 12, 15, another one is starting from 7, 12, 15, then 7, 12, 15 will be logically smaller alias. Oh, now I'm confused. Definitely I'm gonna confuse. I will get confused. I'm not. I will get confused. Not confused. Gods. So day 76 of DSA. Is it 76 or 77? I feel like it should be 77 or something. Maybe last few days I haven't solved that, so the days has been changed. Otherwise it should be 70, 75, 77 or 78 around. Given an array of n integers, okay, I got this intuition, but the thing is, if I have to calculate the alias, then what I'll do? Ten, 22, 9, 33, 21, 50, 41, 60, 80. I will just try to map it with the problem that I solved before. Let's see how it goes. First, let's focus on the LIS, how we are calculating LIS. Okay, suppose if I have to use what we say, recursion, then at each step what we will do? We will start from rdx equals to 0 and last equals to -1, and then you will start. Bro, use parenthesis. Okay. Okay. Now what I will do? Simply you will start exploring. So if last equals to -1, then you will take 10. Another option, you are not taking 10. Okay. Second, now you took 10. Now you have options 2. Can you take 22? Yeah, you can take 22. So another option, you are taking 22, and then another you are not taking 22. So now still you have 10. Okay. The third option, now you have reached to 9. 9, you have option take or not take. You cannot take it, so you are not taking it. Simply one option only. So now what you will do? You will say, okay, now after 9 you will say 33. You will reach to 33. 33, you can say, yeah, you have option take or not take. So 33 taking and not taking. Another option 21. 21 you cannot take. 21 you cannot take, and so you will jump to 50. 50 you can take or 50 you cannot take. Okay, so these are the options how you are going to explore all the paths. But how will you decide whether to? Okay, now at this moment, what you will get? You are at first step, right? Suppose here you have two options. You are not taking, you are taking. That means at the end, what you are going to get? You will get result from left, and you are going to get result from right. If you have to decide which one to take, you can decide it by just checking. Okay, so right now what we are going to get? We are getting count 1, we are getting count 2. So what is, and based on that you are deciding which one is the largest count, and you are taking that. Correct? If the first one is greater, then you are taking first one, I mean yeah, left one. So you can say left, and you can say right. Based on that we are taking. So now we are not focused about what we are getting from it. Definitely still we need to find longest LIS. So we need somehow count total length. But with that we need some sort of, like, whenever we are making two decisions, like left, you are taking left, right, then you have two options which one to take. At each step you will say, okay, this is a smaller one, this is a small. If both are equal and this is big number, suppose here you are getting, from here you are getting 10 25, and from here you are getting 7 25. Okay, then you will say, okay, big, small. If both have same length, then you will simply go for it, for this one, because this is the smallest one number and you want lexicographically smaller one. Okay, good. So you will say, okay, this way we can do it. But how many variables we need? If we are going to do it using recursion, if solving it using recursion, okay, there will be many problems, bro. First thing, how we are going to store it? How are we going to store the result? This is one problem. And second thing, what I feel, okay, second thing I feel, we are exploring the path. Here also we are exploring the path. Okay, different paths. Every time, like, we have two options, take or not take, and whether take is possible or not. If not, then there will be one. So max two branches and minimum one branch will be there. And if we wanted to make decision, like which one to keep, which one not to keep, then definitely we need two things. First is the length, so far that we you explored, and second is the uh, first element that you considered. Okay, first element you can get, like, whenever you are exploring, then that element will be the first element for that particular subtree. So based on that you can get the number, but you also need to return the result. So if you are exploring and you are not, suppose you are not doing one thing, like you are not storing the result and you are just returning the array that you have explored so far. So okay, then it's like you are returning an array. Oh, it will be very difficult, bro. Not very difficult, it will be little time consuming. Why I haven't minimized it? So let me see what are the different tutorials for it. Come on, man. Solution. Okay, what I'll do, let me build a table. So at each step we will be having something. Okay, now we have an array that will be having different numbers. Okay, now for each number what needs to be done. Okay, 0, 1, 2 up to n. If the n is n and here is 0, 1, like we are representing -1 with 0 pseudo index. So 0, 1, 2, test n. n no, 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 there will be total n plus 1, so it will be up to n. Okay, n equals to 0, then you are getting 0, 0, 0, 0, 0, 0. Okay, now the thing is we need to retrace it. So what we were doing, each step, if we always have two options, take, not take, and we have to decide. So take is nothing but where you are just taking the current element as I plus 1 and you are taking jth element, right? So ith you can say. You are not taking this element, it means your j will remain same. So these are two options, and for this option there is a condition, like if j equals to -1 or you can say array of I is greater than the last element that you covered or that you took, j -1, because j is starting from 0, so j -1 equals to -1. Okay, these are the two conditions. Now I just wanted to see, so you will start feeling it. At each I and j you are making decisions. But right now what you are doing, suppose you are not getting same result, I mean if you are getting same from take and not take, will it be possible you can get same result from two string if you are not taking? Yeah, it's possible. And then the only problem will be like the element that you are getting at the end. Suppose from one you are getting and from another you are getting No, it's not possible, right? 3, 4, 5, and from another you are getting 7, 6, 9. Now you need to consider this one because this is the smallest if you are comparing these two. That may not take. If you are taking, last was Z. How to do it? And here also last was this something. I lost into it. Bad. No, let's forget about timing. Timing 20 minutes I wasted. Not wasted, I just explored. So last was say at every time you were making decision, then suppose you are at ith index. Okay, now you have two options: take, not take. Suppose you have, then how you will decide? If the length is one is bigger and one is smaller, if equal, then we need to decide. Then need to decide. Yeah, so I'm just thinking about it like how to do it. Suppose you are at a particular index. Let's say you are at I comma z, and here, so it's basically solution. It's a combination. Whenever you are getting I and j, it is basically a result of table of I plus 1 and we taking. If the both are feasible, take I plus 1 and j, not j, but I. That means you current element you picked. Second, table of last element is the last still it's last element. Okay, so now if you have to decide which one you should consider. So first, if both are equal, if unequal, take bigger one. Okay, perfect. Examples I will see. Okay, I will use this example 1, 3, 2, 4, 6, 5. First I will let me try to derive the solution, then we'll jump into it. Take bigger one. Yeah, if unequal. If equal, we need to decide. And how to decide it? If both are equal, that means okay. In the one, what you did? So you started exploring from here. This is I, and you explored from here. So last, when was it? Last. This is the last. Okay. So definitely you picked. So this is a part of an array or subsequence, longest subsequence so far. And another you got it, but this is not part of it. So this is part of it. Okay. Z is the last one. Can I say I just have went out here? Shall I compare I with Z or last array of I and array of last? If I'll compare both, what will be the scenario? God, God level course. I don't know if it is the right approach or wrong. Let me take examples. Then only I'll get it. So what I'll do? 1022. I will fill this array and then I will go get to know exactly what's how many elements are 1 2 oh no 1 2 3 4 5 6. That means 7 rows I need to build. Okay, so 1 2 3 4 5 6 7. Oh come on man, अबे हो जा. God. So let's say like this. These are the rows and 0 1 2 3 4 5 6. So okay, and there will be 7 till 7. So when 7, then definitely you will say 0. And how many indexes will be there? Last could go up to -1 to n. So -1 to n. That means 0 1 2 3 4 5 6 7. Okay, now let's just start filling 0 at a starting. When everything like index is getting overflow, then it will be 0. Else what are the conditions for filling up anyone? Okay, so if the 0, that means -1. So -1. Okay, now you are at, you can say 6, index number 6, and you have to decide. Okay, so let me just say it. Array of last. Max of you will say I. Else another option table. Right. So okay, the same thing is here 0 means -1 1 0 1 2 3 4 5 6. So at the starting it's -1. So -1, that means 0. So you will get what? Okay, array I haven't written, but 1 2 3 1 3 2 4 6 5. So 0 1 2 3 4 5. Wow, coincidence. So at a starting, when you are at -1 index, then definitely you will say, okay, I'm taking it, and then tell me the result. So definitely it will be 0. That means it will be 1. Okay. Now you are at first index, or your last value is 1. You will say 0. So 0 is the last value, and now you are at where? You are at sixth index. Wait a minute. There are 6 elements, right? Why I kept till 7 then? Come on, man. 30 minutes wasted. 0. Here it will be 1 5. So you are taking 5. Fifth index you are talking. Okay, we are considering about it. Okay, so last is -1. That means you haven't taken anything. So it will be like you are considering this element, plus you are looking for the further exploration. So definitely all are 0. So I'm taking directly. Okay, now. Okay, so if we talk about 0, so now the last value is 0, or you can say, yeah, 0. 0 means 1. 1. So last value is 1, and now you are checking for 5. So definitely you can consider 5, right? So what will be? So okay, you will say, okay, I'm considering it. So one option is you are considering, one is not considering. So if you are considering, then table I plus 1, and it will remain I. So okay, I means here it will be 6. So 0, or so it's like 1 plus 0. 1 plus 0, or another option is like where you are not taking. So here it will, if you won't take it, then it will be something like table I plus 1 and j. J is nothing. Bro, it's very complicated to explore it in this way. But let's do it. I'm not getting, otherwise I will not get it. So okay, 0. 0, you are taking last element 0, and now you are adding 5. You wanted to check for 5, so 5 is bigger than this last element, so definitely you can consider it. So 1, and plus you will say table I plus 1 I. 1 plus 5, it is 0, and another is 1 plus j. J is 0. 0, that means okay. So okay, this one or last one. Okay, this index plus, so yeah, both are 0, then 1. So you will say, okay, no problem, I will take 1 will be there. Then you are talking about 2. First index, last is 1 and 5. So 1 is 3, then also you can say 1, and then okay, then 2, about 2. So 2 problem is 2 is okay, 2 is also smaller than this, so definitely you can take it. So you'll say 1. Okay, 4, so you will say 1, and now it's about 6, or you can say now it's about 5 you are taking, and 6, so you cannot take it, so you will say 0. And now if we talk about 6, okay, last value is 5, so obviously you cannot take it, you will say 0. Okay, now if we talk about 4, 4 is 3, so 3, okay, 4 is 6, so we are considering this 6, fourth index, or you can say, okay, so 6, about 6. If last is -1, then definitely you can say, okay, I can take it. So if you are taking it, then what will be value? It will be 1 plus, you have two options, take or not take. So can you take it or not take it? You have to check it. Yeah, so last is -1. Okay, one thing. I think I missed something. So last is -1, so definitely you can take it. So you have take option 1 plus I. I means 4. 4 means here this one 0. And another option Z 1. Uh, you are not taking -1. Okay, then that will be 1 plus 0 or 1 plus 1. I mean, if I'll fill this array, I will let me fill at least some up to some extent, then I will get idea. No, no, it won't work. What my gut feeling says. It says you should fill it at least once. You will get your concepts will be clear, more clear. So if you are at 4, so 4 is your ith, I value is 4 and j is -1. So if it is -1, then you will say 1 plus I. I will remain, I means 4. So 1 plus 4. So if you will go to the 4, so you will say okay. This is the 4 one, right? Hmm. So I plus 1, that means hey, leave it. So here you are checking for this. So 4 means here actual 4 will be 5. Okay, 4 4 4 4. So 0, 1 plus 0. And another option is you are going to check like okay, you are not skipping it, so it will be -1 only, so 1 you will get. Okay, another thing 4 0. Now you are at 0. 0 means first. Okay, 0 means first. So okay, j is 0 and I is 4. So if j is 0, you can say j is 1. Actual j is 1, but pseudo element index will be 0. Oh, I'm not sharing that. Now you will say 4 and 0. 4 and 0. 4 0 means last is 1. 1, or you can say last is 0. This is the last index, so you can take it. Now you have two options, you can take or not take. So if you are taking, that means you will move to I will become this. So you are taking it. So I will be 4. So 4 means 1. 1 plus 1 2. Another option where you are not taking, then it will be like the same value will remain here. So this one and this one. So j 1. So definitely you will be said it is 2. Now you are at 1. So 1. Now you will say okay. Now the thing is okay. You will say again 4. You are getting 1. 1 from it. 4 means 1. I mean this one. I make mistake. 1 only I'll get. No, it's not going to help me. It will help me, but I'm not. My brain stopped working. What? Let me see how they are solving. It's easy to watch the tutorial.
Now, if you have been following this DP series right from the first, you know the rules. The rules are very.
Bro, I want. My gut feelings is you should try it first. Let me see how much time I faced. Oh god. Oh god. So let me do one thing. I have a table. Now once I will start exploring from it. So we have to go to. So what are the ways of reaching IJ? You will say. So this is how we constructed I and J. Correct? Yeah. Here the condition is okay. Let's do one thing. So let's call it J minus 1 equals to minus 1 or J minus 1. So this is the condition I and J. Okay. So suppose now array is filled. This is filled array, right? If I need to construct the solution, what is the options? Like we will start from here, from 0, from n minus 1 you will say, and here you will say minus 1 1 0 0 1 and till n. So here, so you will start from this location. I will start constructing the solution. So what I'll do, simply I will say if this is this and this is this, and then you will say max. You are taking max of both. So you will start from here, I believe. Yeah, then only you will go reach to this end. So now you have two decisions, whether you want to go this direction or this direction. Which one will be larger, you will go to this. Suppose this is bigger one, where you are just taking this option. Another option is you are not taking this, but you are taking somewhere here, so you will reach till here. Now these two options again, you will reach to this, and you will say, okay, let me explore these two options and see. I mean, you will be at one place. Okay, one more thing, when you are comparing it, if the if both are equal, God, when I solved it, never. So I will start exploring the options. Let me do one thing. What is the oh, I don't want to see the editorial. 10 to the power 3. So I will do one thing. I will create full table. We need full table. Table is nothing but here. You will say, okay, I will do first n is equals to length of array, and then I will do one thing. So here 0 for underscore in a range n plus 1, because definitely we need n plus 1 array. Okay, for underscore in range n plus 1. So this is an array that we are creating, and what we'll do, base condition is 0, then we will start constructing from for I in range. Okay, so you are starting from n minus 1, because for n you already minus 1 and minus 1. For j in range, you will say n plus 1, that means till n you are going. So if we talk about last equals to say minus 1, and here you will say two condition, take if possible. So you will say if last equals to minus 1, or array of I is greater than equals to greater than array of last. Yeah, so what I will do, that means you can get it. So option 1, let me say option 1. So at starting you are just taking option 1 equals to 0. So if option 1 possible, then what I will do, option 1 plus what you are doing, table I, God, you are moving to I plus 1. Okay, And what exactly you are doing? Last will become current element will become your last element. So whenever you are taking I, definitely you have to move I plus 1, because index represent I plus 1. I mean whatever index you are, because you just shifted one. Okay, so one thing. Option 2 is nothing but where you are just taking, not taking. And last will remain last. So here you will say J. So these are the two options. And return, okay, table of I and J is equals to max of op1 and op2. Okay, so this is the, now I'll print table. Okay, let I don't want to print it. Simply I'll do one thing. For I in range, you will say we are going to go till n. So n will be n minus 1, 0 to n minus 1. For j in the range, you can say n plus 1, because I want to see all the options. Now you have two options. So every time you have two options. Check both. Check both the option if possible. If, okay, so first thing, last will be j minus 1. If last equals to minus 1, or you are getting 1 plus why don't do, okay, I will do one thing. Not take. Not take means you are just doing one thing. Table of I means here represents I plus 1, and j represents z. That means whatever the last value you have, you are keeping the same. Okay, good. And now if we'll say last equals to minus 1, or array of j greater than array of last, then you will say 1 plus table of I plus 1, and okay, I plus 1. Option 2. Result, I will say result is nothing but this array. And if take, here you will say if take greater than not take. Simply what you will do, if take is greater than not take, then that means you are taking this element index, you are considering it. Alright, so you will say result dot append, and take is nothing but here array of I. If take less than if not take is greater than take. This is second scenario. If not take is greater than take, then simply you are not doing anything, right? Oh what? One mistake I did. I equals to 0, j equals to 0. While I less than n plus 1 n and j less than n plus 1 I mean. So you will say you will keep on checking, and every time when you are taking, you have two options. Okay, if take, then I will say okay, do one thing. You are moving to I plus 1 j plus 1. Okay, now you will say you are moving I equals to I plus 1 and j equals to I plus 1. If not take, then simply what are you doing? You are not taking it, so I will be I equals to I plus 1 and j equals to j will remain j because you are not making any change to will be the same. Okay, else that means both are equal, both are equal, then what you will say, compare the last value. Will there be possible any condition where you are getting equal? How will you compare if you are taking it and you are not taking it? What the heck? When you are not taking it, then at starting if last custom. Hmm. I'm missing some part. 1 hour I took. Okay, what I do? Both are equal. Compare the last value. Compare the last value. Okay. Now I I'm starting from start, but the problem is only when both are equal. Suppose I'm getting without taking and not taking and take and not take, both are equal. So how to compare like which one is the right one? There are multiple possible options. So if you're not taking, that means this is the number, largest number in this, so you can compare it with something. But what about it? How to do it? No, it won't work, I believe. Take How will I compare it? Let me watch the tutorial better. First I'll see if he created tutorial. I wanted to see. Where are you, bro? What is the name of that person? I forgot the name. Verma. Aditya Verma. Black Adventure.
सो आज से हम लोग लर्निंग प्रोग्रामिंग स्टार्ट करेंगे. काफ़ी अच्छा टॉपिक है. काफ़ी
Printing longest
हाई प्रैक्टिस की कंपनी आती है ना, तो काफ़ी इनकम देती है अपने को, और लर्निंग प्रोग्रामिंग ही बेचती है. जैसे मेरी कॉलेज में सबसे पहले आई थी नुटेनिक्स.
Longest increasing subsequence.
केस सैलरी 22. फ्लिपकार्ट की भी 16 है, राइट?
No, it's not there.
केस सैलरी इसकी 22 थी.
Very simple. Write the base case, and before that declare the DP of the same size. So I'll declare a DP of n plus 1 and then write the base case. Now if you look at the code, what is the base case? We just have one base case, which is if index is equal to n, we have to return a 0. So since we're
Wow.
declaring a DP of size n and n plus 1 and assigning everything to 0, since everything is already assigned to 0, we don't need to specifically write for the base case. I hope that makes sense. Next, write the changing parameters. So if I look at the code, these are the couple of changing parameters that we have. So write down the changing parameters in the opposite fashion. Strict rules, easy rules, which we have been following right from the start. So the index will be from n minus 1 to 0. Previous index will be from n minus 1 to minus 1. But here's a catch. If it's a previous index and it is an index, what is the definition of previous index? The previous index. So can a previous index be n minus 1 always? No. A previous index will always start from index minus 1 because it cannot be beyond index or index itself. The game itself is previous index. So this is how you can have these kind of things. Next is copy the recurrence. As simple as it can get. Copy the recurrence and make sure you follow the coordinate shift that I taught you. Follow coordinate shift that I taught you. Okay? Just make sure you do follow the coordinate shift that I taught you. So what I'll do is I will go across over here, and this is how the code looks like. And over here, what I'll do is I'll do a 0, and this is the index which will start from n minus 1, index greater than equal to 0, index minus minus, and I'll have the previous index right starting from index minus 1 till previous index greater than equal to minus 1 and previous index minus minus. Perfect. And now what I'll do is I will simply take this portion and I'll copy paste over here. Once I've taken this, now what I will do is I will be like, okay, let's convert this into a DP. So remember, whenever you convert it into a DP, the coordinate shift has to be done. So the second parameter will always have plus 1 because if you remember, we stored the second parameter in plus 1 state. Over here is the first parameter, it is as it is, and the second parameter goes into the plus 1 state. Okay. So we move the second parameter into the plus 1 state. Over here, this will go off. Over here, this will be DP of 0, and instead of minus 1, it will be plus 1 state. So you just do a plus 1. Once you have done this, and if you try running this, you will see that this is indeed giving you the correct answer. No, it did not. Why? Because you are at n minus 1 and you're doing an index plus 1. So make sure this is declared for n plus 1. Because n means you don't have an nth row. So just make sure you have this. So as you see, it is giving time limit exceeded because we missed a greater than equal to over here. Nevertheless, so greater than equal to over there. And this should be running. Perfect. So that's how you can convert this into a simple sorted tabulated code. Now if you're following my DP lectures right from the start, you know the space optimization technique. Yes. Whenever you see something like index plus 1, what comes to your brain? Yes. Space optimization. So what you'll do is you will just space optimize this because in order to compute index, you're just requiring the next row, just the next row. So please show you the time complexity is still big O of n squared, but the space complexity. And now what I'll declare is I'll declare a DP of size n. That is what I'll declare. I'll try to declare a DP of size n. Where DP of I signifies the longest increasing subsequence that ends at index I. Remember this. DP of I signifies the longest increasing. Similarly, if I ask you, what is the longest increasing subsequence that ends at 11? You can say 5 can be a part of it, or you can say 4 can be a part of it. Both of them can be a part of it. So I can say it can have a length of 2 because either 5, 11, either 4, 11. It can still have a length of 2, right? Next you go to 1. Can I have a longest increasing subsequence? Any one before 1. 5 cannot be before 1, 4 cannot be before 1, 11 cannot be before 1. So the longest increasing subsequence will be of length 1 again. 16. For 16, I can say I can have 1 before 16. So that's one of the ways. I can say I can have 4 before 16. That's one of the ways. I can say I can have 5 before 16. That's one of the ways. I can definitely say I can have 5 and 11 before 16. So these are the four lengths. There can be a lot of other ways as well, like 4, 16, that you can figure out. But can I say the longest that I can have is if I pick 5, 11, and then 16. So I can have a length 3. For 8, can I have 16 before 8? No. Can I have 1 before 8? Yes. So 1 and 8 can be together. Can I have 11 and 8? No. Can I have 4 and 8? Yes. So I can have 1 and 8, 4 and 8, 5 and 8. I can't see more than length 2 that ends at over here. So I can still have a length 2. Thereby, I know all the longest like at 11, a length of 2 ends. At 16, a length of 3 ends. So if I know for every index, this is the possible answer. So can I say this is the LIS? Which means I can have a sequence something like 5, 11, 16 or 4, 11, 16 for that reason. Well, anyone before 1, 5 cannot. The longest, the time complexity is still big O of n squared, but the space complexity has been boiled down to n into 2. Now, is this the best solution? No. The best solution uses a weird method, tabulation method. Like I personally feel if you know this, you know this. Otherwise, you cannot intuitively write it. That is what I feel. So it's a tabulation method that you have to learn. It's a different way. So let's take a quick example and try to understand the tabulation method. So 5, 4, 11, 1, 16, 8. Okay. Let's take this array. Okay. And now what I'll declare is, I'll declare a dp of size n. That is what I'll declare. I'll try to declare a dp of size n. Where dp of I signifies the longest increasing subsequence that ends at index I. Remember this. dp of I signifies the longest increasing subsequence that ends at index I. For an example, if I ask you, what is the longest increasing subsequence that ends with 5? You'll be like, the length is 1 definitely, because before 5 I cannot have any 1. Similarly, if I ask you, what is the longest common subsequence, longest increasing subsequence that ends at 4? Again, 5 cannot be a part of it, so you'll again say the length is 1. Similarly, if I ask you, what is the longest increasing subsequence that ends at 11? You can say 5 can be a part of it, or you can say 4 can be a part of it. Both of them can be a part of it. So I can say it can have a length of 2, because either 5, 11, either 4, 11. It can still have a length of 2, right? Next you go to 1. Can I have a longest increasing subsequence? Any one before 1? 5 cannot be before 1, 4 cannot be before 1, 11 cannot be before 1. So the longest increasing subsequence will be of length 1 again. 16. For 16, I can say I can have 1 before 16. So that's one of the ways. I can say I can have 4 before 16. That's one of the ways. I can say I can have 5 before 16. That's one of the ways. I can definitely say I can have 5 and 11 before 16. So these are the 4 lengths. There can be a lot of other ways as well, like 4, 16, that you can figure out. But can I say the longest that I can have is if I pick 5, 11 and then 16. So I can have a length 3. For 8, can I have 16 before 8? No. Can I have 1 before 8? Yes. So 1 and 8 can be together. Can I have 11 and 8? No. Can I have 4 and 8? Yes. So I can have 1 and 8, 4 and 8, 5 and 8. I can't see more than length 2 that ends at over here. So I can still have a length 2. Thereby, I know all the longest length. At 11, a length of 2 ends. At 16, a length of 3 ends. So if I know for every index, this is the possible answer. So can I say this is the LIS? Which means I can have a sequence something like 5, 11, 16 or 4, 11, 16 for that reason. I can have both of them as the length. Yes, I can have both of them as the length. So like both of them as the longest. So I can have both of them as the longest increasing subsequence, and the LIS will be the max of all DPIs, max of all DP of index, where I ranges from 0 to n minus 1. This is the formula. But the funda is, how do you compute this quotient? That's important. That is the key. So you figured out what's the thought process behind this algorithm. So now let's again copy paste the same example of 5, 4, 11, 1, 16, 8. Now let's try to figure out the DP. Okay. So what I'll do is, however, keen focus. I know one thing for sure. Even if there does not exist any element before that, I repeat, even if there does not exist any element before that, I know the length will always be 1. The max length will be 1. He itself. So initially DP will have all the values assigned to 1 because he itself will be the maximum length. Okay. For this guy, which is index 0, for this guy, does it have any previous elements? The answer to that is no. So this will still stay as 1. Let's move to the next index. Does this guy have any previous element? The answer to that is yes. This is the previous element. But this 5 is actually greater. So this cannot be a part of subsequence. So this still stays as 1. And I don't have any other previous elements apart from 5. Let's move next. When I move to second index, this guy doesn't have previous elements. Yes, these couple of guys are the previous elements. Can 5 become the previous of 11? The answer to that is yes. 5 can become the previous of 11. If 5 can become the previous of 11, and if there is a subsequence that ends at 5 of length 1, can I say if I involve 11, the subsequence will be of length 1 plus 1, and that will be a length 2. Because I know there is a subsequence that ends at 5 and is of length 1. So if I take that length, if I take this length, and if I add it to 11, I'll add 1 to this length, which makes it 2. Perfect. This was a previous which can combine with 11. Next previous is 4. Again, this is of a subsequence length 1. Like I know there is a subsequence of length 1, LIS. There is an LIS of length 1 that ends at 4. So can this be with 11? Yes. This plus 1 is 2. That is already 2. So no need to update it because I already have a length 2. Perfect. Let's move ahead. 3. So I'm moving ahead to this index. Now I have a 1. Can this be a part with 1? No. Can this be a part with 1? No. Can this be a part with 1? No. So no one can be a part with 1. So 1 will be only having a length. Okay. Let's go to the next. When I'm at 4, what do I have? I have 16. Okay. Can 5 be a part of 16? Yes, it can make 5 and 16. So 5 has a length 1, adds a length 1, makes it a length 2. Can 4 be a part of 16? Yes. Length 1 adds 1, 2 is already there. Can 11 be a part of 16? Yes. I say 11 can be a part of 16. And 11 in itself is a length 2, which is 4 and like 5 and 11. So this length 2 can be a part of 16, makes it a length 3. So this can be updated to length 3. Realize since you stored the longest till 11, that helped you in attaching it and making it 1 more when it got a greater element. Got it? That's how you get 3. Can 1 be a part with 16? Yes. 2, but we already have better 1, so no need to take it. That's how you figure for 16. Next, move to the next 5. You are at 8. For 8, can this be a part? Yes. So length 2. For 8, can this be a part? Yes. Length 2. For 8, can this be a part? No. For 8, can this be a part? Yes. Length 2. For 8, can this be a part? No. So eventually you'll get length 2 only. So this is how you fill up the entire DP table. Once you have filled up the entire DP table, figure out the maximum, and that's 3. And that is going to be your LIS. That is going to be your length of LIS. So can I say, what am I doing? Can I say, I'm actually starting from index 0 and I'm going on till index minus 1. That's what I'm doing. I'm starting from 0 and I'm going till n minus 1. And whenever I'm standing at, let's say, 16, I check for 5, 4, 11, 1. So I'm checking all the previous indexes. So can I say, I'm checking all the previous indexes from 0 till index minus 1. And what am I checking? I'm saying, can the previous be a part of mine? If it is, then the answer will be 1 plus whatever previous had. And I will store that in my current guy. But I need to compare that with whatever I am at current. I need to compare that. Whatever I have, and if the previous is smaller, if the previous is, okay, I am saying, can the previous be a part of mine? If it is, then the answer will be 1 plus whatever previous had, and I will store that in my current guy. But I need to compare that with whatever I am at.
What the heck? I'm not getting it. Previous 0 to index minus 1, last minus 1. Okay, current minus 1. Okay, so at a particular index, whatever, like if that can be part of our DP. Okay. Okay, that means all the elements that are before it can also be part of DP.
Current, I need to compare that. But I need to compare that with whatever I am at current. I need to compare that. Whatever I have, and if the previous is smaller, if the previous is smaller, then just add 1 to it and then compare with myself. If it is greater, then I'll store it. And at the end of the day, the max of everyone will be my answer. So without actually waiting, let's go back and try to code this. So just comment this off. Now what I'll do is I'll just declare a vector of dp of n, comma, I plus plus. Perfect. Now I will have a previous which will be from 0. I will go on till I will like previous plus plus. Okay. Now, can I say if array of previous is lesser than array of I? Can I say dp of I will be max of dp of whatever is there plus dp of previous? As simple as it can get. And once is the power 1. So yeah, again why dp? Because you're storing the previous things. That's how you can easily do this LIS. Now if I ask you the time complexity, again if I submit this, you'll see it will be giving you it yearly. Because the time complexity is still n squared. Yeah, if I talk about the time complexity, it is still V go of n squared. But the space complexity has now boiled down to V go of n. Now this solution will be required if you want to trace back the LIS. If you want to trace back the LIS, this solution will be required. So it's time that we now trace back the LIS. Okay. Now we'll be learning how to print the LIS. That's very important. So let's learn how to print the LIS. So till now we have understood how to figure out the length of the LIS. But what if someone comes up and says, "Hey, can you print me the LIS?" Can you actually print the LIS? We can. What if we apply some backtrack? Can we print it? We can. So the backtrack that we will do is, as of now we were creating a DP array. If you remember well, we were creating a DP array and we were initially saying everyone to be 1, right? Now let's create one backtrack array, another array. Okay, you can call whatever you can make. Just name it as hash or something like this. So let's create one more array. Okay, and make sure everyone is assigned whatever index you have. Make sure everyone is assigned the index himself. So this hash will say, this hash array will say who was the previous index to it. You'll understand. Like for example, over here 5, it does not have any previous, so it will have 1, and it will say this 5 ends at, like before 5 we at 5 itself, so no 1. Right. When we reach at 4, it will still be 1, and this 5 cannot be a part of it. It cannot be a part of it. So let's keep it as 1, and this will also be staying as 1. Now whenever we are at 11, what we do is, we take 5, the value is 1, we add 1, and we update it to 2. Is that what we do? Definitely we update it to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11, before you there was 5. So at 11, can you say before 11 there was this index 0. So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. So we are at 11, there was 2. Now we are at 4. 4 had 1, so 1 plus 1 would have been 2. You can update it or you cannot. It's still the same value. Okay. Next you go to 1. 1 says this cannot be, this cannot be, this cannot be. It still stays as 1. Next, you go to 16. It says that 5 can be a possible answer. So 1 plus 1 will give it 2. So this guy will be 2. So please update it to 2. So what I'm saying is for the 16, before this there was 5. So let's update this to index 0. Perfect. Next this is 4. 1 plus 1 would have been 2, which is already there. Next we have an 11. It can also be a part. So this is 2. 2 plus 1 would have been 3. Perfect. Why don't you update it to 3? And if this guy is coming before 16, there's an index 2. So index 2 will be updated. Amazing. 1 cannot be an answer because 1 means 1 plus 1 is 2, and we already have a 3. So 1 cannot be an answer. Let's move to the next. We have 18. 5 can it be an answer? Yes. If I'm taking 5 as an sorry, this was 168, not 18, my bad. Yeah. So for 8, can 5 be an answer? Yes. 1 plus 1. So thereby this becomes index 0. Can 4 be an answer? No, because we have already updated this to 2 while we were doing it 5. Can 4 be an answer? 1 plus 1 2, same. 11 no. 1 plus 1 2, 16 no. So apparently your hash array is storing something like this. And the maximum value you got was at this index 4. So you start at index 4, take up that value 16. Next, you go to the previous index. And you can easily get by hash, which is 2. So you go to 2. So at the second index, you see a value 0. So you go to 0. At 0, you see 0 itself. So you stop. So apparently index 4 has 16. Index 2 has 11. Index 0 has 5. So if you reverse it, it's 5, 11, 16, which is your answer. In this way, you can easily get your answer. So if I go back to the code, you just need to create one more hash array. So make sure you just create a hash array of n size. And whenever you enter, just make sure hash is nothing but the index itself. Okay. And what you need to do at the next step is just go across. Whenever this is getting updated, so instead of writing this, you can simply write and plus 5 to 0. So you go to 0. At 0, you see 0 itself. So you stop. 8. Can 5 be an answer? Yes. 1 plus 1. So thereby, this becomes index 0. Can 4 be an answer? No, because we have already updated this to 2 while we were doing it 5. Can 4 be an answer? 1 plus 1 2, same. 11 no. 1 plus 1 2, 16 no. So apparently, your hash array is storing something like this.
So this one won't be the part of it. Then what?
So thereby, this becomes index 0. Can 4 be an answer? Means 1 plus 1 is 2 to the 16. Before this there was 5. So let's update this to index 0. Perfect. Next this is 4. 1 plus 1 would have been 2, which is already there. Next we have an 11. It can also be a part. So this is 2. 2 plus 1, this is 1. Next you go to 16. It's
16. Wait a minute, bro.
like before 5 we at 5 itself. So no 1. When we reach at 4, it will still be 1, and this 5 cannot be a part of it. Over your 5, it does not have any previous, so it will have 1, and it will say this 5 and it's at like before 5 we at 5 itself. So no.
Okay, you kept the same index like you are the.
When we reach at 4, it will still be 1, and this 5 it cannot be a part of it. It cannot.
5 cannot be part of it.
Not be a part of it.
Yes.
So let's keep it as 1, and this will also be staying as 1. Now whenever we are at 11, what we do is we take 5, the value is 1.
It's 1.
add 1 and we update it to 2. Is that what we do? Definitely we update it to 2. Remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So at 11, can you say before 11 there was this index 0? So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. So we are at 11, it was 2. Now we are at 4. 4 had 1, so 1 plus 1 would have been 2. You can update it or you cannot. It's still the same value. So next you go to 1. 1 says this cannot be, this cannot be, this cannot be. It still stays as 1. Next, you go to 16. It's say is that 5 can be a possible answer. So 1 plus 1 will give it 2. So this guy will be 2. So please update it to 2. So what I'm saying is for the 16, before this there was 5. So let's update this to index 0. Perfect. Next this is 4. 1 plus 1 would have been 2, which is already there. Next we have an 11. It can also be a part. So this is 2. 2 plus 1 would have been 3. Perfect. Why don't you update it to 3? And if this guy is coming before 16, there's an index 2. So index 2 will be updated. Amazing. 1 cannot be an answer because 1 means 1 plus 1 is 2. And we
Okay, so you are taking the recent or most closest to it, and that most closest will store the previous index and the previous and so on.
we already have a 3. So 1 cannot be an answer. Let's move to the next. We have 18. 5 can it be an answer?
So yeah. Oh, banjo.
Yes. If I'm taking 5 as an sorry, this was 168, not 18, my bad. Yeah. So for 8, can 5 be an answer? Yes. 1 plus 1. So thereby this becomes index 0. Can 4 be an answer? No, because we have already updated this to 2. While we were doing it 5. Can 4 be an answer? 1 plus 1, 2, same. 11, no. 1 plus 1, 2, 16, no. So apparently your hash array is storing something like this. And the maximum value you got was at this index 4. So you start at index 4, take up that value 16. Next, you go to the
Print longest increase in subsequence. So almost 40 minutes, 30 minutes I am taking. Let me take example 1, 3, 2, 4, 6, 5. So first I will create DP array. So for each at a starting 1 1 1, that means that particular element is the part of it. Okay, now what we are going to do, we are going to check from I minus 1 till here if there is anything. So for it there won't be anything, so you will say okay, 1 will remain 1. For 3 you will check if there is anything before it that is bigger than, or if we are adding that, if there are any number smaller than this, so you will say 1. Okay, 1 can be part of it, so you will say okay, 3 plus. So okay, what is the DP of 1? You will say 2 1, so it's like 1 plus 1 2, so it will be updated to 2. Okay, now you will say 2. For it, what will be the maximum value? So for 2 you'll say okay, 1 can be part of it, you will say yeah, 1 can be part of it. So what is the DP of 1? So it will be, say you will say 1, so it will be 2. Now 3. Can 3 be part of it? No. So you will say okay, keep it 2. Now 4. We are going to 4. So 4, for 4 you will start comparing again. So 4 you will check with 1. So can 1 be part of it? You will say yeah. So it can be. So what is the DP of 1? You will say okay, it's a 1. So you will say okay, 1. So 1 plus 1, 2. It's bigger than this, so you will say 2. Now again you will say for 3 you will check. So for 3 what is the DP of it? So you will say okay, it's 2. So 2, if you are gonna consider 3, then definitely you will be able to consider 2. So definitely it's bigger than the recent one, existing one. So you will say okay, it could be 3. 2 plus 1, 3. Okay. Now another, you will say okay, what is the DP of it? So you will say 2, 3. So if you want, you can override or not, it's same. Now if I'll go to 6, 6 for 6, what is the? So you will say 1, you will say 1. First it will be 2, then okay 2, then you will say okay, no 3. For 3 it's 2, so you will say okay 3 is okay. Then it will become 3. It's 2 plus 1, 3. Okay. Now you will say 3, 2 plus 1, 3, and now you will say 4. 4, 3 plus 4. 3 plus 1, 4. So you will say okay, no problem, 4 is the right one, because here you are getting. So now you can get like 1, 2, 4, 6. Okay, so that's why 4. Now 5. For 5 you will check again. So 1, okay, it is smaller, you will say 3 it's smaller, and 2 it's smaller, and 4 it's smaller. Okay, so out of these, which is maximum? I'm just taking that directly. So 3. 3 plus 1, 4. Okay, now this is the thing. Now we want to print LIS. So let's do one thing. Two, 3, 4, 5. So these are the indexes. Okay. Now what I'll do, I will start from here. So for it, is there any previous element? You will say no. So it will remain same 0. Now for this, okay, for 1, 3, what is the? So 1 can be part of it. So you will say okay, 1, if it can be part of it, then you will say okay, it will become 2. So if it will become 2, you will say okay. Now what is the index of it? You will say 0. When you are considering 0, then the previous element will be 0. So you will say, you will change it to 0. Okay, good. Now when you are moving to 2, so what is the like 2 comparing with 1? So yeah, it could be part of it. 3 cannot be part of it. So 2. So what is the DP of 2? It is 1. So 1 plus 1, it will be 2. So it will be 2. Here it will be 2, and what will be previous index of it? It will be 0. Okay. Now for 4, what you will do? For 4 you will start comparing again. 4, like if you will compare with 1, so it will be 1. 2, you can compare, take it 2 or 2. Any one of them you can take it. So maximum whatever you are going to take, so it will become 3. And so now you can take 3 or 2. Any one of these you can take. So okay. So now it will become, suppose you are taking this, so it will become 1. Okay. Index. Now you are at 6. So 6, for 6 you will say okay, 4 is the max value. So you will say okay, let me do one thing. So it will become 3 plus 1, 4. Now you will say okay, for 4, if it is the case, then it will be something like okay, 6, 4. 4 is coming when you are taking this one. So there is the index of it is 3. And then you will jump into 5. For 5, it is like the minimum value 3. 3 plus 1, 4. So it will be like 3. So let's take any one of these. So if you are starting for this, so there are two. So if you will start for this, then you will say okay 4. So what I will do, I will start with 6. You took 6 first in, like okay, you took the 6. Now what is the previous of it? 3. So 3 you will go 4. Okay, now you will go to 4. So oh man, what is this? First you took 6 and you will check what is the DP of 6. No, not yeah, you will 6. See the index of 6. It is 3. It is pointing to 3. Go to third index. It is 4. Then 4. Check what is the index of it. It is third index. I mean, just go to the third. Third you will check 0, 1, 2, 3, 4, 5. Okay, so 3. It is point. You are at 4. So you will pick the 4. Now you will go to 3. 3, 1. 1 means okay 3. What is the value of 3? 4. Well, now it is pointing to 1. 1 is 3. 3 you will go to 3. So 1 is point 3, and now you will go to 1. So 1 is 0, pointing to 0. 0 means 1. So 6 4 1 3 4 6. These are the options. But this is the thing, something you are getting. But if you notice, like we can get a smaller one. 1 2 4 5. This is the smallest one, right? Smallest LIS. Hey, what is this? 1 2 4 5 is also possible, right? Index wise. Not by element wise. 1 3 4 6. That means we need to take decision. So whenever you are getting two equal things, so you will pick smaller index. So here based on DP you won't be able to decide, based on this one you will be able to decide. So let me note down the solution for it. So for n is nothing but len of array. Okay, now what is, you will say array in n, and I will create two arrays, dp and prefix pre, just let me call. Okay, so everything will be here in dp, everything will be at a starting. Okay, 1 1 1, and here it will be like 0 1 2 3, because these are the indexes of that particular element. I You are checking till I. Okay. You don't need to even write zero I. The I is nothing. Now you will say for each you are comparing. Oh, MZ. If array of j is lesser than array of I, it means it could be part of our. Okay. One plus dp of j. That means okay. So these two conditions if satisfying, then what you'll say dp of I is nothing but 1 plus dp of j, and okay, pre of I will be j. So this is one backtracking. Now you will do one thing. First you will find the dp of I. Okay. Once you will find it, so you will say okay, let's say small index is to 0. If dp of I is greater than, okay, once you got this smallest index dpi, then what you'll do, now you need to traverse it from backtrack. Oh god, backtrack, and what you will do, what is time right now, bro? 1047 44. Now you are at particular I and you will make result. I will do one more thing. Before it, break it. So first thing, zero to n elements dt, and pre is nothing but here you will say oh, what you did. So we got this. Now our next thing is we have to start from first. I in range n. So we are checking for each element for j in range I. Now you'll say first thing, array of I, array of j is lesser than array of I, and dt of greater than dp of j, dp of I. That means okay, it's a possible option. So you will say of I becomes 1 plus dp of j, and one more thing, pre will store, pre of I will store j, because j is the index that you are taking. Okay, finally add the backtrack. Find the max index. So mi is equals to 0 first index, and Maxwell is equals to dp of 0, and now you will start from here. And if uh, dp of I is greater than Maxwell, mi will be I, right? Find the array. Result using backtracking. So what you will do, now you are going to backtrack. So while greater than equals to 0, if okay, mi, what you are going to, so first mi, not array of I. So this is the first thing. What now? Okay, now the next thing is uh, if mi equals to previous of mi, not mi, break, else mi equals to pre of mi. Now you are backtracking, and finally result dot okay, let me do one thing. Print dp dp1 to, let me take for this one. That's correct. That means TP is okay, but the problem is here we are doing somewhere array of I. This is the fake when I never did this. Wow, really, it's a very horrible experience, I will say. I took 2 hours to solve this really bad, and I will forget it. I know. Really, it's a very horrible experience, I will say. I took 2 hours to solve this really bad. My stream is fucking crazy. I will forget it. It's not working even at all. What the heck? My suggestion getting garbage. Like, so, lead code. If I'll continue like this, then definitely I'm not fucking gonna uh, get something. What is something, bro? What do you want to do? You are given an integer in nums of n length n. Alice and Bob are playing game. Alice chooses. Okay, let me break. Let's then for other day. Otherwise, it's like you are going to just overwhelm. Bye bye. Take care and see you in the evening. Yeah, we need to set up like we need to. I need to make changes. It's not working otherwise. Take. Thank you. Let me transition. Okay, guys. So that's all for this stream, and thank you so much. Yeah, I was expecting to solve two problems, but one problem only took 2 hours. So now things are complicated. I mean, complicated in the sense like these are the problems that are the not so easy to solve. So definitely this will take time, and if I won't take like I won't revise them, definitely I will forget them as well. So it's pretty important. Like you should revise, and now time comes like now it's time to revise the things because there are so much things in pile up and so many problems are piled up and I need to revise them, otherwise it's like you are learning from one end and you are forgetting from another end, so there won't be any benefit of it.